To talk more about ozone depletion and its recovery, I'm joined in the studio now by physicist Dr. Markus Rex, who is also an expert on atmospheric processes. Thank you very much for being with us today. All right, now in that piece, we saw that some parts of the ozone are recovering, whereas parts of the layer is also getting worse. This is a bit confusing, but what is the current situation?
That's indeed confusing, and the reason for that is that these chlorofluorocarbons, these CFCs, can destroy ozone efficiently when the temperatures are really, really cold. That's typically only the case above the Arctic and the Antarctic in the polar regions, and when the temperatures drop to levels of about -78 or -80 degrees Celsius, then these CFCs can result in the formation of an ozone hole. In the Arctic, that only happens every once in a while, and in some Arctic winters, the temperatures are just not low enough to produce large ozone losses, and in others they are, and therefore the situation is very different from year to year.
Okay, let's talk about these holes then over the poles. What impact do they have then in real terms on the ground?
That's twofold. The thinner the ozone layer is, the more UVB radiation we get at the ground. And UVB radiation is harmful. It can cause sunburn. It can also cause skin cancer. And therefore, we try to avoid large exposure to UVB radiation. The other effect is that there are strong links between the ozone layer and changes in the ozone layer and changes in climate. And therefore, any change in the ozone layer has some consequences for climate at the surface where we live. And these linkages are poorly understood, and we need to do more research to find out what the links are.
All right, now stopping CFC production has apparently reversed the trend of ozone depletion. How reliable are these measurements and predictions that have led scientists to say this?
In the long term, we can safely say that the CFCs, as long as we all stick to the Montreal Protocol, that international treaty which bans the production of CFCs, as long as we stick to that, the ozone problem will go away by the end of the century, and the ozone holes then will no longer appear. In the short term, it's much harder to predict because of that link to the temperatures. So if the temperatures in the stratosphere, the upper layer of the air, change as part of climate change, then we may even get a worsening situation, particularly in the Arctic, for the next 20 or 30 years.
We know that we've seen countries come together with the Montreal Protocol and sign up to stop CFC production. There's been success there. But in terms of CO2 emissions, why is it so difficult to get countries to agree to cutting emissions?
That's much harder to do. We have that nice example of the Montreal Protocol, which really banned the production of CFCs and which is a great success in protecting the ozone layer. But it was much easier to do that because we could replace these CFCs by chemicals which have similar properties, and the consumer doesn't notice even that the CFCs have been replaced by other things. To reduce the emission of greenhouse gases is much harder. Therefore, we need to reduce the energy consumption. We need to try to produce a larger fraction of our energy from other sources, and that's a much harder and much more costly process.
It most certainly is. Okay, well, we're going to leave it there for now. Dr. Markus Rex, thanks for being with us today.